last programming task I need to complete is the project for the Seymour micrographic panel that I am using as my operator interface, also known as Human to Machine Interface Device, or HMI for short. Let's see what this takes to accomplish. I use the Seymour micrographic panel as my operator interface to execute the various motion profiles I have set up in the CTRIO module. For reference, this includes homing the axis, jogging the axis left or right, and commanding my two predetermined motion profiles to perform. Again, the motion profiles are the trapezoid and S-curve moves. I start my Seymour project by opening the Seymour Micro application software as seen here. I next select the Make a New Project button in the application window. I name my project Motion Control Demo - Seymour Micro Project, select my panel type, which is part number EA1 S3ML, a 3-inch touch panel with 5 different colored backgrounds, and then select the PLC protocol I will be using with the DirectLOGIC DL05 PLC. My PLC protocol will be the AutomationDirect K-Sequence protocol for the DirectLOGIC DL05, 06, 105, 205 PLC series and the 350 and 450 CPUs. I click OK and the main application screen will open showing the work area, navigation window, and the object list window as seen next. Although the Seymour Micro panel can have multiple screens for my needs, I decide to use just one simple screen that will allow selecting the various move operations. I use dark green for my background color as I show here. Let me give you a quick rundown of the Seymour Micro software's application screen. The work area indicated here is the real estate area that I will use to place my operator devices, such as push buttons and other objects such as static text. The navigation window is where the various tabs that allow me to make adjustments to my screens can be found. I can work with the different functions and features from here and also get information about my connected panel. I can also update the panel's firmware from here. It is always a good idea to start a new project with the latest programming software and firmware loaded into the Seymour panel. You can find a short video on the Seymour Micro website that covers updating panel firmware under the site's Support Tools tab. Look for the How-To Videos pull-down menu and you'll find the Panel Information - How to Update Panel Firmware video listed under the Panel category. The object list window shown here is where I'll pull from the available standard objects to place on my screen, and also included are predefined special objects I can use. I can also save any special objects that I have created and may want to use in future applications. Next, I'll set up my communications port on the Seymour panel that will communicate with my DirectLOGIC DL05 PLC. I decided to use the optional Seymour serial port power adapter, part number EA-MG-SP1, which is designated as COM port 2. This second port allows the panel to be connected permanently to the PLC, while at the same time I can connect my PC to the panel's built-in port, COM port 1, for downloading my program. This will save time with disconnecting and reconnecting communication cables. Here I open the Panel Manager under the Setup drop-down menu within the Seymour application software. I make sure the selected PLC protocol for my application shows AutomationDirect K-Sequence 5/06/105/205/350/405. I next select the communications port that I want to configure. In my case, COM port 2. I use 1 for my station number with a baud rate of 9600 and the parity set to odd. I leave the timeout and poll times set as 10 milliseconds. Now that I have my communications and PLC protocol configured, I can import the tag name CSV file I created earlier from the DirectSOFT5 programming software. I select Tag Names Database from Import under the File drop-down menu. I select Motion Control Demo-DirectSOFT5 Project.CSV file and click Open. A dialog window labeled Import Tag Name Database from Excel/CSV file will pop up. I make sure the From DirectSoft checkbox under the Import Option area is checked so the imported data is treated properly. I next click the Import button. All of the data records that are located in the CSV file will be stored in the Seymour's Tag Name database. A bar graph shows the progress and an import completed message will pop up when the import is done. Seeing is believing, so to make sure my tag names were imported, I opened the Tag Name Database utility under the Database pull-down menu. Shown here are the nicknames I had created within the DirectSOFT5 software. The assigned functions I exported from the CTRIO Workbench utility and later imported into my DirectSOFT5 nicknames can also be seen, along with a few Seymour internal system tag names. Okay, I now have everything ready to start adding various objects to my panel's screen. I'll start by adding some simple text to identify my screen. I'll use the static text object by clicking on it from the library, dragging it to my screen, and dropping it in place. The text will identify my screen and would be very useful in allowing me to see quickly which screen I have active if I were using multiple screens. For my application, I type in Motion Control for the text. I select None for the frame style so the text will occupy the least amount of screen space. For my text alignment, I select the center icon under Align. I'll use a font format setting of 8 by 16. I next stretch the static text object and locate it at the top of the screen. As a note, the Seymour 3-inch micrographic panel has a screen size of 128 by 64 pixels. I set my screen's title static text to 128 pixels wide by 16 pixels high. For reference, take a look at the short video on the Seymour Micro website that covers how to use static text under the Site Support Tools tab. Look for the How To Videos pull-down menu and you'll find the text/messages how to use static text video listed under the text/messages category. Next, I'll add my first functional object, a push button. I click, drag, and drop the push button object from the library list onto my screen. The push button dialog box is now open. I want the push button to have a label, so I click the label checkbox and type jog for my text. I keep the text position at the top by having the top radial button checked. For displaying purposes, I type in left for both the off and on condition text. For my needs, I use the object's defaults for color, align, and font. I select button 1 for my frame style. I then use the square style 1 for the push button's object style. I want the push button signal to be on or true only while it is being pressed on the Seymour's panel, so I check the momentary on radial button for the object type as shown here. Finally, I need to assign a tag name to my jog left push button. Because I was able to import the tag names earlier from the DirectSOFT5 CSV file, I can use the Seymour's Tag Name Database utility to look for the imported tag name for my push button. I recall that the tag name JogLeft PB was assigned to PLC address C1 in the DirectSOFT5 ladder logic. I select the JogLeft PB tag name from the drop-down list. I click OK and then size and position the push button on my screen for a uniform look. In a like manner, I continue adding my other push button objects for my demo project's jog right, home axis, trapezoid move, and S-curve move pulse profiles. I size and position each object on the screen to make for a uniform look. The Seymour Micrographic panel has a built-in alarm feature that I can set up to alert me with a pop-up message of any problem that may come up during the operation of my application. I'll use the alarm feature to alert me whenever one of the over-travel proximity sensors is actuated. I program the alarms by opening the Alarm Control Setup under the Programming Software Setup drop-down menu. To add an event, I click in the first pull-down box under the Event column for Alarm Notification. This is priority number 01. A dialog box titled Alarm Control Setup will pop up. Next, I select the tag name titled Over Travel Left from the tag name drop-down list to use for my first alarm notification. I'll click the On Radio button so that my alarm is visible when the tag name is true. I check the beep checkbox so I can have an audible signal. I also check the backlight checkbox, select the color red, check the blink checkbox, and leave the current backlight color selected. This will cause my backlight to blink off and on from red to the normal background color of the screen being displayed during an alarm condition. I want to display a banner message during the alarm condition, so I check the banner message checkbox and type Over Travel Left for my alarm message. I click OK when finished and then create the next alarm notification as priority number 2, which will be used for the Over Travel Right alarm message. As shown here, when any of the alarm tag name notification conditions are true, the screen will show the message in the upper area, blink back and forth from a green to a red background, and sound the beeper. This action will continue until the alarm condition is cleared. Here is shown my finished Seymour micro screen that I will use to control the various move profiles for the motion controlled demo. Again, I can home my axis, jog the axis left or right, execute a trapezoid move, or execute an S-curve move. I also have the ability to be alerted to any alarm conditions by way of alarm messages on the screen, along with background color changes and sounds. Let me take the time to point out a really nice feature that is built into the Seymour programming software. What is the feature? How about the ability to test the Seymour panel through simulation? Here I click on the simulation icon and an on-screen representation of the Seymour panel will be displayed. Also shown is a list of the various tag names that were created as I developed my project. Using the list and the shown screen objects, I have the ability to change the status or values of the various bits and words. This will allow me to test the operation of my panel. Let me demonstrate. Here I use my mouse to click on the home axis push button. I can hear a beep that indicates the push button has been pressed, and I can see in the simulation tag list that the value for home axis PB, bit C0, turns from off to on and back to off when released. I can also click on the value for over travel right tag name, bit X1, to simulate an over travel condition, turning its status from off to on. I now see the simulation screen blinking between its normal background color of green to a red background color, and I also see my over travel right message in the upper left area of my screen display. In part 8 of this video series, I will demonstrate the various pulse profile moves that I have created with the integration of the SureStep stepping system with a CTRIO high-speed counter module controlled from a DirectLOGIC DLO5 PLC and commanded by way of a Seymour micrographic panel. Please join me.